All right, so you already created a table of contents for adding and subtracting fractions. Before I give you guys the steps to do this, we're going to kind of do just some modeling and show you how you can model with adding. You could do it with subtracting as well, but I found examples of adding, so we'll start there. You can write, why don't you write one of these down? Everybody write the first one down. So the first one's 1/4 plus 2/4, and then underneath that is a circle that's split into fourths. All right, I'm going to use orange for the 1/4, and let's use green for the 2/4 so we can see where they're going. So if I have the fraction 1/4, we've already talked about modeling. How would I model this? Jamie? From this down here, what would I have to do?
You would have to color in 3/4.
Color in 3 of them?
Yeah.
What number does that say up there?
Oh, 1.
1. So how many do I color in? 1. So to show 1/4, I'm coloring in 1 out of 4 pieces. Is everybody okay with that? For 2/4, how many pieces do I need to color in?
2.
2. So I'm going to pick 2 different ones and color in 2/4. But when we add, we combine things. So I'm putting in the same circle here in my same hole, because both of them have 4 parts that make up a whole. And you can easily see that now instead of 1/4 plus 2/4, I have how many? 3/4. Pretty simple, right?
Yeah.
Okay, let's just look at the next one together. You don't have to draw it. You can if you want to. So I'll do 3/8 in green. There's already 8 pieces here for me, so I need to color in 3 of them. And then I have 2/8. I'll change that to a different color. And what's my answer?
5/8.
5/8. And then the last one, I have 1/3 plus 2/3. Here's 1/3. Here's 2/3. And what am I left with?
3/3.
3/3, but what is that?
1.
It's 1 whole. 3/3 means we colored in the whole entire piece down here. So far, so good? All right, so now instead of modeling these, I'm going to give you the steps. So take a second to write these steps down in your notes. So step 1, for adding and subtracting fractions, you need to make equivalent fractions with your least common denominator. That is the same exact step that you guys just did with comparing fractions. So we make equivalent fractions with your least common denominator. And what method can we use to do this? What method are you guys doing on your page? Who said that? Marcus? Ladder method. Do the ladder method. If you need to write that down in your notes, write it down. So we make equivalent fractions with your least common denominator, and we use the ladder method. Second step, you add or subtract your numerators. Whatever operation it is what you have to do. So if it says add, you add. If it says subtract, you subtract. So this is almost the same as comparing. For step 2 on comparing, it said compare your numerators. Now we just replace that with add or subtract your numerators. And then step 3 is simplify if possible. You're not always going to be able to simplify, but if you can, you have to simplify. I will not count it as a correct answer unless your answer is completely simplified. Okay, so simplify, remember we need to divide. You need to maybe put a division symbol in there, write divide, whatever you need to do. Okay, simplify, we divide our numerator and denominator by the GCF. So go ahead and write this first example down. I have 1/3 plus 1/6. And we're going to walk through this one together. Step 1, make equivalent fractions with your least common denominator. Well, let's do the ladder method first. What can I pull out of 3 and 6? A 3. How many times does 3 go into 3? And how many times does 3 go into 6? 2. Can I pull anything out of 1 and 2? No. So I'm going to make my L and multiply. What's 3 times 1?
3.
What's 3 times 2? 6. So we need to make our denominators 6. What can I multiply 3 by to get 6, Taylor? 2. In order to make an equivalent fraction, we need to do that to our numerator as well. My new equivalent fraction, 1 times 2 is 2, 3 times 2 is 6. Do I have to change this fraction over here?
No.
No, because it's 1/6 that already has 6 in the denominator. So I'm going to rewrite it down here. We have 2 over 6 plus 1 over 6. And step 2 is you add or subtract your numerators. Well, we're going to add then. What's 2 plus 1?
3.
3. Denominator stays the same. You never add your denominators. You never subtract your denominators. It stays the same. Okay, just like it did when we modeled them back here. Our denominator is still 4 parts make up one whole, so that stays. So 4 and 4 in our denominator is still 4. Same thing over here. 8 parts still make up one whole. That doesn't change. So our denominator is 8. So we have 3/6, and then let me rewrite that down here so we can simplify. What can I divide 3 and 6 by?
3.
I can divide it by 3. So we're going to divide by 3, divide by 3. What's 3 divided by 3?
1.
What's 6 divided by 3? The answer is 1/2. Questions? All right, I have more examples to do on the next page over here. They're going to start pretty easy, and they'll get a little bit harder. So I have the steps up there just in case you didn't get them all written down yet. Step 1 is make equivalent fractions with your least common denominator. Do I have to do step 1 on any of these? No. Who can tell me why I don't have to do that? Taylor? Yeah, they already did step 1 for you. They already have a common denominator. So you don't have to do anything for number 1. You just have to go straight into number 2. Add or subtract your numerators, and then step 3 is simplify if possible. So let's do one together. Let's do the first one. Go ahead and write it down. 3 over 20 plus 5 over 20 equals, who can raise your hand and tell me? Tyler? 8 over 20. So that's step 2. Step 3 is simplify if possible. Can I simplify this?
Yeah.
Yes. What's my GCF between 8 and 20? It's 4. Very good. So we're going to divide by 4. Divide by 4. 8 divided by 4 is 2. And 20 divided by 4 is 5. So your answer is 2/5. Let's do one more together, and then I'll have you guys do the last 2 on your own. So this one's subtraction. Be careful. Make sure you're looking at your operations. I already have common denominators. Step 2 is you add or subtract. So we need to subtract. What's 3 minus 2? 1. Denominator stays the same. And can I simplify 1 over 9? No. You're done. So take a minute to do the last 2 on your own. Alright, so this one down here, 2 plus 5 is 7. Denominator stays the same. Simplify by dividing by your GCF, which is 7. And we get 1/2. The second one, 4 plus 6 is 10. Denominator stays the same. Divide by your GCF. The GCF is 5. 10 divided by 5 is 2. 15 divided by 5 is 3. How'd we do on those? Good. All right, let's do some more practice. So here are 4 that do not have common denominators. They're set up vertically here. Same thing. This is saying 1/4 plus 5/8 is just going up and down, which is kind of convenient because then you could do all your work right here and you don't have to worry about squeezing it in anywhere. So let's do this one together. Our denominators are 4 and 8. So if we do the ladder method with 4 and 8, what can I pull out? A 2. Let's start there. A 4 also, but I heard a lot of 2s. What can I pull out of 2 and 4? Another 2, and I'm left with 1 and 2. So if I make my L and multiply, what's 2 times 2 times 1 times 2? 8. So your least common denominator is 8. So we need to make sure both of these have a denominator of 8. What can I multiply 4 by to get 8? Good. So we're going to do times 2, and I get 2 over 8. Do I have to change this one? No, but I'm just going to rewrite it so they're underneath each other. And then I add my numerators. What's 2 plus 5?
7.
7. Denominator stays the same. Can you simplify?
Yes. No.
No. You're done. Questions on that one? All right, go ahead and do the next 3 on your own. It's 10. I'm going to rewrite this one. Add them together. 3 plus 4 is 7. Denominator stays the same, and again, you cannot simplify. Questions? Divide them by your GCF. The simplified answer is 1/2. The next one, 7 minus 6 is 1. Denominator stays the same. You cannot simplify that. 1/12 is your answer. The third one, 5 minus 1 is 4. Denominator stays the same. Our GCF is 2. So we're going to divide both of these by 2, and our equivalent fraction is 2/3. How do we do on those? Good. All right, we're running out of time, so let's see. We'll start with this tomorrow, so go ahead and start packing up.